I'm going to start the recording. Welcome back, everyone. The most important announcement this week is on the screen, Lab Test 1. So Lab Test 1 will take place in week 5 during this window. Information is now on Moodle. And probably most importantly for you, the lab test practice versions are available. Okay, so if you have any questions, firstly go and read the information for lab test 1 and try it. And if you have any questions, post them in the forum. Now, in this morning's lecture, where some of you were there, I asked the group if they wanted to do some revision. And I thought next Monday in the afternoon, I'll do some revision. I think it'll be around 4 p.m. Sydney time. I'll let you know though. So if you want to come to that tutorial, feel free. And I'll go through some of the questions. We can solve them together, okay? All right, well, I hope you are enjoying week 4. This is a sort of an advanced tutorial, deeper understanding. So what I thought we could do is tackle some of the H questions, the harder ones, together. And yeah, you can let me know what's happening. Now we have a grand total of 11 people here. So what I would like everyone to do is turn on your microphones and say hello. I want everyone to say hello. Turn on your microphones. Give me a wave if you want to turn your camera. Say hello.
Hello, hello. Hello.
Hello. Don't be shy. I want to hear from everyone.
Hello, hello.
Hey. You're coming in loud and clear, guys. All right, thank you for that. So let's share the PDF. There are some calculus questions. There are some algebra questions. I think we could do some of each, okay? So let me know how things are going, either in the chat or on the audio or whatever. And we've covered all of this stuff in the lectures. So I thought we could start with this one, the limit definition of the derivative. This is not particularly hard. It just takes a little bit of time. So I thought we could do that one, and then maybe this one, and then maybe we can switch over and do some algebra. Yeah, this one's an interesting one, but let's see how we go. All right, part D. Let me share my Chrome tab. So let me know what's going on in the chat, or however you want to do it. We've got this function, and we want to compute the derivative from the limit definition. So if you remember, it's just this limit here. Okay, and like I've said in lectures many times, there's a definite process for these kinds of questions. You try to simplify this as much as possible, and the last thing you do is take the limit. Okay, so if we differentiate this, we actually know exactly what it is, right? Say we're differentiating that, right? It's a power function. So the half comes to the front and you decrease the power by 1. Okay, so we definitely know what our answer should be. And in fact, the question kind of tells us this as well. But let's do it using the limit form, okay? So I'm just going to write down this quotient and I'm going to try to simplify it as much as possible. And the very last step is to take the limit. Okay, so here I replace x with x plus h. Here it's just f of x. And down here I've got h. Now, what I would like to do is somehow get rid of this h. Okay, and I think I've shown you this in lectures, and you might have seen it in the algebra as well. You can multiply this by a factor of 1. Okay, that involves the reciprocal of this top bit. So watch what I do. So you can see this is just 1 here. And all I've done is I've changed the sign here. A little bit like the conjugate that you see in the complex numbers course. Okay, now it looks like I've actually made the problem much more difficult, but it's not true, right? If I expand this, I'm going to get this, and down the bottom, I get this. Okay, so the x's disappear. Hooray! You can factor out the h's, they disappear. And you're left with this. Okay, so the question now is, I haven't taken my limit, but if I take my limit as h goes to 0, this will go to 0, and I can combine. So if h goes to 0, this you can replace that with 0, and I get ta-da! Yes! Awesome. Yeah, brilliant. Yeah, mamma mia, that's great. Excellent work. Ooh, Luigi's going to come in. I know, Azalea, amazing. Now, if you didn't know this step, it would be super difficult to do it, right? It would be super difficult. Yeah. So this is one of those cases where knowing the trick helps you a lot, okay? And we multiplied by a factor of 1 where we just changed the sign like a conjugate, okay? Yeah, amazing. All right. So if you have any questions for this one, let me know in the chat. Let's do another H question. I'm not sure if you saw this definition at school. So for those of you who were recently at high school, did you do these kinds of problems at school? Did you use the limit definition? Yes or no? Let me know in the chat, or you can just tell me. Okay, Anna's familiar with them. Kevin, not. Brendan, yes. Yeah, first principles, right. Jordan, yes. Okay, so some of you will see the familiar things here, and for some people it will be new. Either it's okay, and it's definitely worth learning, right? Because you might get tested on this a bit later. Okay. All right. Let's do. Is there any other H ones? Oh yes, let's do this one. All right. So you've got a function. It's x times absolute value of x. Calculate these limits, and what does that tell you about the derivative at 0? Okay, so let's have a look at that first as a picture, and then we can do it as like just writing it down. Okay, so that's the question. Let's, first of all, let's plot the graph. Okay, so there it is. So did somebody say GeoGebra? So there it is. Now, who can tell me on the chat from the picture, does this function look like it's differentiable at x equals 0? Who can tell me on the chat? Does it look like, just from the picture, does it look like this function is differentiable at 0 or not? Anna says yes. What do you think? Anna says yes. Anyone else? Kevin says yes. Does this graph have a tangent line at the origin? Okay, well, it looks nice and smooth, right? And if even though it changes definition there, the join is a smooth join, okay? So it looks like, at least from the picture, that there will be a tangent line there. But let's sort of analytically look at that and see if we can prove it. Okay, so back to the document camera, and let's work this out. So the first question involves, part of the question says, what is the limit as h approaches 0 from the right? Now, from the graph that we just saw, this kind of looks like it's going to, like the slope of the tangent is going to be 0, right? But let's actually just work it out. Okay, so let's do that. Oh, sorry, that's a h. All right, when h is positive, it's coming in from the right. This is, right, we can sort of make that, it's x squared, and x is greater than 0. And this will be negative x when x is negative. Okay, so what's this going to be? Who can tell me, is it going to be, is this value going to be h squared or negative h squared? Who can tell me in the chat? Who can tell me, what's this first term going to be when we actually apply it to this function? Who can tell me in the chat? Yeah, h squared or x squared, however you want to do it. Thank you, Anna and Kevin. And when x equals 0, this thing is just 0 squared, which is 0. So that disappears. I can cut off the h, and it's just 0. Okay, so that kind of confirms what we thought from the picture with the horizontal tangent. Okay, so what about the second one? That's probably going to be 0 as well. So in this case, h is coming in from the left, so that's over here. When x is negative, the function is negative x squared. So it will be something like this. Okay, again, disappear, cancel, and you get 0. So what do we notice about our two limits, the right-hand limit and the left-hand limit involving the derivative? They're equal. And so hence f dash equals 0. Okay? State the value of f dash. That's exactly what we wanted. Now, if these didn't happen to be equal, or if one of them existed, the other one didn't, then of course you wouldn't get your differentiability. Yeah, great, awesome. Okay, so you wouldn't get your differentiability if these two things were not equal, then this cannot exist, right? All right, we are making progress. All right, last question for calculus, and then we can switch over to algebra. All right. So let me go back to the PDF. Now, this is just a routine question, but I thought it's interesting anyway, right? So here's a function, x to the power 1/3. Is the function differentiable at x equals 0? Okay, that is the question. Okay, so let's go and have a look on GeoGebra, and we can pretty much work it out from just looking at GeoGebra. Okay, so here's x to the power 1/3. Okay, now it looks like it's a nice smooth function, right? But the question is, does it have a tangent line at x equals 0? And what's the slope of the tangent line? So who can tell me what is the slope of the tangent line at x equals 0? Who can tell me on the chat, or turn your microphones on? Kevin. Yes, Naomi, it does look like a vertical tangent. Exactly, Oliver, undefined. So you're all correct. Thank you. So Kevin's got it right because he's saying that the slope of the tangent is like infinity, okay? So it doesn't make sense. Naomi is absolutely correct because it is a vertical tangent, if you can call it that, so no problem. And Oliver is also correct in the chat saying that, well, it's undefined, okay? So just by looking at the graph, you know that that definitely doesn't have a tangent line at x equals 0, and therefore the function can't be differentiable at x equals 0. Okay, so another way you can do it, and that would be the reasons, right? So if I go back here, it says give reasons. Well, that's a whole bunch just from the picture. There's another way of doing this as well, and let me just quickly show you that, or share that with you. So this is question 5. Let's actually just compute the derivative and see what happens. So it's a power function. The third comes to the front, and you decrease the power by 1. So you can see what's going to happen. This isn't defined at x equals 0 because you're dividing by 0. Okay, so it's not defined at x equals 0. So this expression, or this thing, does not exist, or is not defined, however you want to put it. Okay, so that's a H question, but I think it's an interesting one, both from a sort of an algebraic point of view and also from a visual or picture point of view. All right, folks, let's move on to the algebra. Okay, so there's lots of questions for algebra this week. I might just do some of the H questions, I think. Yeah. So some of these questions are longer rather than difficult. So these are not particularly difficult questions. I'm not sure why that's a H. I thought probably the most interesting one here was 6. So, you're using vectors to sort of prove a geometric result there. Okay, so I thought we might discuss that. Okay. All right. Well, let's have a look. Use the dot product to prove the diagonals of a square intersect at right angles. So this is a very ancient problem, and of course we know it's true, and you can prove this in a number of different ways. A simple way is just folding the paper, right? Use origami or something to fold the paper. But let's see how they want you to do it is by using vectors. Okay, so let's have a look. Yeah, all right. So this is question 6. So I'm going to draw a square-like object, and I'm going to label it. Okay, and what the question is asking you to do is to say, okay, consider the diagonal line segments. What they want you to show is that these angles here are 90 degrees. Okay, and you know that these lines are all equal in length, and the internal angles are all 90 degrees. Okay, so what we would like to do here, at least the way I'm going to do it, is to show that, I don't know, the vector BD is perpendicular to the vector, say, AC. Okay. So who can tell me in the chat, so by that I mean they're perpendicular, right? The angle is like 90 degrees. So who can tell me in the chat, who can tell me what is a strategy here? How might we solve this problem? We all know it's true, but can anyone suggest a strategy here? What might a strategy be here? Who can tell me? Kevin, dot product equals 0. Azalea, AC dot BD equals 0. Both correct. Excellent. So let's try that. Okay, so our strategy here will be something like, as you mentioned, show that BD dotted with AC, equals 0. Okay, so we know the lengths of these sides are all equal. Let's work out how we can write these sort of diagonal vectors in terms of the sides. I think that's probably the easiest way to do it. Okay, so let's have a look at the vector BD. So the vector BD using the triangle inequality is vector BA plus AD. So we're making things a little bit more complicated to do this, but it'll be worth it in the end. Okay, so that's by the triangle rule of addition. Yeah. And so what about AC? Well, with AC, I can go AB plus BC. Okay. Now, what is the relationship between these two vectors? Who can tell me? BA and AB, what is their relationship? Who can tell me on the chat? Who can tell me? What is the relationship between this and this? Right, Azalea. So they're sort of, yeah, they're the same vector, but they just point in different directions, which is perfect. Exactly, Naomi. Thank you. And AD and BC, they're equal vectors. Even though they're in different spots, they point in the same direction and they have the same length. Okay? So this works because it's a square. Okay? So now let's go back to here. And we'll use this information and this information to solve the problem. Okay. Now you could distribute this. The dot product you can distribute it like you normally would with regular multiplication. But before I do that, I'm just going to change this a little bit. So let's go BA equals negative AB and BC equals AD. So I'll switch that one to AD. Okay, so now we expand it like we normally would. Oh, maybe I shouldn't have expanded it there. Oh, no, it's okay. Yep, thank goodness. Okay, so now these two things cancel out. Why? Because the dot product doesn't matter if you like the order doesn't matter. Okay, so bam, bam. And now for these things, we can write this one like this. So if you dot something with itself, it's the square of the vector's length. Okay, and why is that? Because AB is the same length as AD because the whole thing is a square. Okay, so this angle, the dot product between the two vectors really is, and that means the angles must be 90 degrees. Diagonals. They must be right angles. Yay, we did it. Okay, so that's it. Now notice that this obviously won't work unless this is a square. So you know the shape, of course, is super important. You know the other shape it works for is things like a kite or something like that. You know, and what else do you know about these diagonals? They bisect. So this bisects that, so they cut them in half. Cool. Cool. Okay. So let me know what's going on in the chat, people. Do you need me to revisit any of the explanations here? Is something not clear? You can also turn on your microphones if you have any particular questions. Aichen, why are these two things equal to 0? Good question. Does anybody know in the chat? It's a good question from iChat. Okay, so the length. So what is this? AB is simply the square of this length. And AD is the square of this length. This is a square. So this side has to have the same length as this side. It's a square, I-Chen, okay? Okay. So it wouldn't work unless it was a square, or, you know, if this was a rectangle, you couldn't say that, right? So, yeah. Okay. Thanks for your question. Great question. Keep them coming, all right? So let's go back to the PDF. And what do we got? What do we got? Yeah, maybe we can discuss this one. Okay. So I think I have, I don't have a full solution for that, but let's discuss it anyway. Okay. So you've got a triangle formed by these 3 points. Find the coordinates of the midpoint of the side BC. Find the angle BAC. Find the area of the triangle. And find the coordinates of the point D on BC such that AD is perpendicular. So there's quite a lot of questions to do there. So I might cover some of them, but not do all of them. But let's see how we go. Okay. So question number 8. So I think this is long rather than just hard. Okay. So they give you the 3 points, and that should form a triangle. So the first step, find the coordinates of the midpoint M of the side BC. Okay, so let's draw a picture, and then we can get an idea of what's going on. Okay, so I'm just going to draw it like this at the start. Now it turns out that this triangle is a right-angled triangle, okay? But you don't know that when you start the question. So I'm just going to draw it like this, okay? And what you want is for the first part, you want the coordinates for this point here, okay? So how can you do that? Well, let's say this is the origin, okay? I'm not drawing any axes. What I would like to calculate is the vector OM, okay? And to do that, I can do it a bunch of ways. What I can do is go there and then go there, okay? And M is the midpoint, so I want half of the vector BC, okay? So let's consider our points. We're told that this is 1 point, this is another point, and this is the third point. Okay, so the vector from O to M, we want that. If we have that, then we know the coordinates of M. Okay, so let's work it out. The triangle rule tells us that we can, to get to here, we can go here to here and then add half of BC. Okay, we know what B is, we know what C is, so we can calculate that vector and just multiply it by a half. So pretty easy, right? Like not a really difficult problem there. So let's keep it going. So OB is this 4, 4, 2. BC is C minus B. So the position vector of this minus the position vector of this. So it's going to be 2, -3, -2. I think that's correct. Yep. So to get OM, you just simplify this. Okay, so let's see if we can simplify. It's a bit of a shame we have a fraction there, but oh well. Okay, so we're going to get 5. So 4 minus 1.5 is going to be 2.5, which is it's going to be yeah, 2.5. So what's that? It's 5 on 2. And lastly, 2 minus 1 is just 1. Okay. So we can now say hence M is just the point 5 on 2, 1. Okay. So not too bad. Not too bad. What about the second part of this question? Okay, so once we complete this second part, you'll see that the triangle that we're dealing with is actually a right angle. Okay, so find the angle BAC. So what we want is this angle here. Okay, so that's the angle BAC. All right, so to do that, can anyone suggest in the chat, how can we find this angle? Who can tell me? Who can tell me? And assuming I don't know it's a right angled triangle, right? Who can tell me in the chat? There are 12 people here. What is your strategy to compute angle BAC? Who can tell me? Cosine rule is interesting suggestion, Anna. I think Naomi is a bit closer. I think they want you to use the dot product for this one. Okay, so you could use the cosine rule perhaps, but I think Naomi's a bit closer to what the way they want you to do it. Okay, so you know that cosine of theta equals the dot product of the two vectors divided by the product of their lengths. Okay, so let's take the dot product and see what happens. The vector, I need to compute AB. I already have the vector BC, so that's easy. So the vector BC is the vector, AB. That's what I want. The vector AB is the vector B minus the vector A, or the position vectors, right? So 4 minus 3, 4 minus 2, 2 minus 1. And BC was this. Okay. So now if we take the dot product, what's going to happen? 1 times 2 plus 2 times -3 plus 1 times -2. No, it's not. Hang on. Let me just check. I'm just checking something. Maybe it's not a... Oh, hang on. You know what I've done wrong? What have I done wrong there? Who can tell me? Yeah, exactly, Jordan. I don't need BC. Okay, what I want is that vector and that vector. Yeah, exactly. I want AC. Okay, not BC. Gosh, I'm getting confused today. All right, so AC, that minus that, that minus that, that minus that. Whew. It's good that you guys are here keeping an eye on me. Okay, so that should be AC, not BC. Oh, it's a fail. It's a fail. Okay, so I want that vector crossed with that vector. Okay, so that's an AC there. AC there. Oh, all right. So let's do the dot product now. Hopefully I've got the right one. Okay, so that times that plus that times that plus that times that. So 3 minus 2 minus 1. Okay, so you know the dot product 0. So cosine theta equals 0. So who can tell me in degrees what is theta going to be? Who can tell me? Yay! Okay, so that angle really is 90 degrees, and you know you can recast your picture like this now, something like that. Okay. Okay, so that's pretty. Well, that's a nice development, assuming you can choose the right vectors to do it. Last part of this: find the area of the triangle ABC, and then find the coordinates of the point D on BC, such that these two things are perpendicular. All right. So the triangle, it's pretty easy now. From the new picture that I'm going to work with, it's pretty easy that because it's a right angled triangle, to get the area, all you need is the length of this, the length of that, and you can apply the area formula. So it's going to be a half times the base times the perpendicular height. Okay. So let's work that out, and we can do that. So I've already got AC up here. I've got AB there. So let's work out. I didn't need these things for the dot product because the denominator was already 0. So that's fine. So let's work them out. And the way you work it out, of course, is just using Pythagoras's theorem, which is nice. So you square each of the components and you add them together and you take the square root. So 9 plus 1 plus 1, root 11. For AB, we've got 1, 2, 1. So 1 squared plus 2 squared plus 1 squared, all square rooted. So you're going to get something like root 6. So now all we have to do is put those together. Okay. And you can simplify that if you want to. And it's probably square units are fine for that. Okay. And the very last one for this particular question right? So the U squared just means square units, right? We don't know what they are. So the very, very last one for this question. Find the coordinates of the point D on BC such that AD is perpendicular to BC. So it's best if you just draw a picture with this one and see what is happening. So what they're asking you to do is to find some point there such that this vector is at a 90 degree angle to this vector. Okay. All right. So what might be our strategy for that one? Who can tell me? Who can tell me? On the chat or turn on your microphones. It's not as easy as the other ones. Who can tell me? Any ideas in the chat? So interesting, Azalea. So you're saying BD, this is lambda times BC, right? So maybe you can get this if you start with this and you scale it back, right? So that's one way of doing it. You just need to find the lambda. So Kevin has suggested something else. Why don't you just take this vector, project it onto this vector, and that gives you the vector BD. Okay, I agree, Azalea. I think Kevin's is easier, but I think your method is okay too. But I think that's the way they want you to do it. Okay, so they want BD is the vector projection of BA on BC. And the importance of having these two vectors is because we actually know what they are, right? We can calculate them pretty easily. Okay, so what does this look like? Well, it's the dot product of these two things divided by this length, okay? And you multiply that by a unit vector in the same direction as BC. Now, in your notes, they combine these two things to get a square, right? Like the square of these things. But this actually tells you something that's more interesting. This is a unit vector in the same direction as vector BC, so it has length 1. And this is like a scaling factor. So it kind of comes back to your lambda before, Azalea. Okay? So once you've found BD, then you can compute BD equals OD minus OB. So you're looking for that, you just take this to the other side. So the coordinate of D, or the position vector, is just BD plus OB. Okay, so when you work that out, you'll get a vector. You don't want BD, you just want OD, right? So this might be the origin, and what you want is like that vector there. Okay, so once you've worked this out, you can rearrange it, and that's the bit you want. Okay, that's what. So from there you get your D. Okay. So for me, the best way to look at these problems is to draw a picture, especially when it comes to projections, right? Because people get confused. It's like, what's projecting on what? And, you know, I don't really know what's going on with the projections and all that sort of stuff. Okay, so I don't have enough time to finish this, but these are the ideas. Okay. All right, folks, couple minutes. Does anybody want to ask any other questions about anything? Don't forget the lab test 1 is next week, and I'm planning to do a revision tutorial next Monday. Not in this class. Oops, sorry, not in this class, but the one in the afternoon. So you'll at least have some revisions, like a revision video or something to go to. Okay, or you can watch the recording or something like that. All right, so let me know, folks, if you have any questions in the chat. You can turn on your microphone if you want, but it's now open to you to ask anything you want. Okay. Question 1D. Is that the algebra or the calculus, Ai-Chen? Is that the calculus? Oh yeah, calculus. Yep. So here it is. Hang on. Yep. Here you go. So is there anything there that is unclear or that's a bit of a mystery? Have a look and let me know. So let me know what you want to talk about, Ai-Chen, if there's a specific part of that you want me to talk about. Yeah, Azalea, that's about right. There's no real surprises in the last. Okay, so if you practice the lab test, you should be fine. Yeah, no problem, Ai-Chen. So you should be fine, Azalea. If you just get familiar with the practice questions, there's no crazy surprises. There's no crazy surprises. All right, I will leave this with you, everybody. Have you got it down, Ai-Chen? Thank you, everyone, and goodbye. I'll see you next week, or see you tomorrow for the lecture. It's a algebra lecture tomorrow, so enjoy. Thanks, Oliver. Thank you, Jungsheng, Naomi, Menglu, Anna. Bye. Azalea. Bye bye. So 886. Bye bye, everyone. Oh, 886, not 86. And maybe see you tomorrow or later on this afternoon. Okay, bye.